Wireless data has given us enormous change in the way we interact with the world. 1G gave us the cell phone, 2G allowed us to send text messages to one another, 3G transported us online, and 4G gave us the ability to download our favorite cat videos from YouTube. We sat down with Peter Gamble, Chief Technology Officer at Skyworks Solutions, to talk about what's next.
As we tried to go to high-resolution video and uploading and downloading video, the 4G network became congested. You want to get a video from your friend, the buffering wheel comes on, you get annoyed, and in a few seconds you say it's not worth it. In 5G, that changes dramatically because your devices, not only will they enable rapid communication, real-time video, but it will enable the devices to go and talk to each other. Let's say you're skiing down the mountain and you say, which run should I take? The device has to go and understand your level of expertise, how many other skiers there are on the mountain, make some decisions in real time and provide you feedback as to what your decision would be, almost acting like a true assistant. In 5G, we're going to upload and download high-resolution video. This will enable things like autonomous driving and seamless interaction with the cloud, as well as immerse ourselves in augmented reality worlds. Studies have shown, by the way, that to do fully autonomous driving, you need about 2 gigabits per second of data. In the US, the average 4G network download speed is around 20 megabits per second. While some of the 4G networks worldwide achieve almost twice this data rate, one of the key aspects of 5G technology is to improve the data rate on your mobile device by more than 100-fold. From a practical perspective, exactly how are we going to do that? In the trade, we use 3 names for these things: QAM, carrier aggregation, and MIMO. We can make an analogy, a simple analogy, to traffic on the highway. QAM is like how fast can the cars go on the highway. Lower QAM, slower traffic; higher QAM, faster traffic. Carrier aggregation is like adding lanes to the highway. So if you have more lanes, you can get more traffic down the highway. MIMO is like adding new roads to the highway. You add more roads, the traffic that can go from one city to the next increases linearly in the number of roads that you have. The problem we have right now is the 4G bands are small and they're already occupied. So we have to look for a place in the spectrum where there's wide bandwidth available. That's millimeter wave. Millimeter wave technology, on the other hand, is like adding an airport, where vast amounts of data and cellular video can be transmitted dramatically faster. The downsides are twofold. The propagation of millimeter waves is more point-to-point, so it's hard to get your signal to go around corners. And the other thing is it takes more current out of the battery. So battery life in a handheld device with current technology would be significantly reduced. And our expectation is the first deployment of millimeter wave in 5G is going to be in applications like fiber to the curb or fixed wireless access, where you need to get from a small cell to a variety of users. So maybe a small cell could handle 20 or 30 users through a technique called multi-user MIMO, where you send beams of data to each of a variety of users. The vision for 5G maps perfectly onto the vision for Skyworks. In the 5G world, we'll connect everyone and everything all the time.